Okay, class, so today we're going to go over chapter 6, preparing injectable medications. Our topic for this video will be parenteral injections and infusions. Our learning objectives are to calculate the volume to be measured when given a specific dose, calculate the amount of medication in a given volume. So parenteral injections and infusions. An injection is a method of administering medication in which a needle or cannula, a small tube, attached to a syringe, penetrates the skin or membrane to deposit medication into either the tissue, the muscle, or a vessel below. An infusion is a type of injection in which a large volume of fluid is administered over a long period through a needle, usually into a vein. Medications given as injections or infusions are considered parenteral. A subcutaneous injection is given into a vascular, fatty layer of tissue under the layer of skin. Most medications given by this route are quickly absorbed. Patients can self-administer medications such as insulin by subcutaneous injection. Intramuscular or IM injection is given into the muscle tissue. So water-soluble medication are absorbed rapidly when administered intramuscularly, whereas oil-based medications are absorbed slowly, which makes you think that, okay, oil-based medications are the ones that are going to hurt the most. With proper training, patients can self-administer medications by IM injection, but this route requires more skill and coordination than the subcutaneous route. An intravenous IV infusion is given into a vein. So large volume infusion, such as 500 to 1,000 milliliters, may be administered over a period of hours, while IV infusions that are 50 to 100 mL are often given over a shorter period, which is 30 to 60 mL. And then we have smaller volumes such as 5 to 30 mL, which may be administered via syringe, such as an IV push medication over a few minutes. Medications given by injection are often ordered in milligrams. So the pharmacy or the nursing staff must select and prepare an appropriate concentration of medication from available stock. The amount of medication is determined using the same methods for calculating liquid oral solutions. So we're going to use the same method of ratios and proportions or dimensional analysis to find out how many milliliters need to be administered to the patient. So, for example, parenteral injection infusion. A parenteral medication is given as an injection or, give you a couple of seconds to answer. Infusion. So again, it's either going to be via subcutaneous, intramuscular, or intravenous. So an injection is given under the skin, so that's a subcutaneous. So when selecting a syringe, choose one that can accommodate at least blank of the volume being prepared. So that would be half. So again, in this case, if you're given a medication that's going to be 2.8 milliliters and you have a 3 ml, 5 ml, or a 10 ml syringe, which one would you choose? So you would choose the one that's either, remember, half the amount. So that would be either the 3 ml or the 5 ml. But of course, the 3 ml would be more accurate than the 5, so you would go ahead and use the 3 ml syringe. You would not use the 10 ml syringe because the measurement won't be as accurate as the syringe that's closest to the volume. So calculating the volume of an injectable solution. So first, the volume of medication to be administered is calculated by both the pharmacy staff and the nursing staff when administered the medication. A small volume less than 20 mL is rounded to the nearest tenth or hundredth. Larger volumes are rounded to the nearest tenth or whole milliliter. So for example, how many milliliters of the medication shown in the label below must be administered to provide 12.5 milligrams to a patient? So looking at this label, midazolam, we have that it's 5 milligrams for every 1 milliliter. Okay, so that's the concentration. So knowing that, we can set up our ratios and proportion. So 12.5 milligrams over the value that we want to know, x mLs, is equal to 5 milligrams over 1 ml. So cross multiply 12.5 times 1, x times 5. So x 5 milligrams is equal to 1 times 12.5 divided by 5. So 12 divided by 5 is equal to 2.5 milliliters. Using dimension analysis, so we put the value that we want as our numerator. So 1 milligram over 5 1 ml over 5 milligrams, x, you want milligrams as the numerator to cancel the 1 in the denominator. So 12 milligrams. The milligrams cancel. 12.5 times 1 divided by 5 gives you 2.5 milliliters. And which syringe would you use? You would use the 3 ml syringe because it would be the most accurate. Calculating the quantity of medication in an injection solution. So use the ratio, proportion, and dimensional analysis method to determine the amount of medication in an injectable solution. So for example, how many milligrams of progesterone are in 2 ml of solution shown in the label below? Okay, so here looking at this label, we see that we have 50 milligrams per ml. And again, in the middle, it's those other label that we have. So we want to know milligrams. 2 ml over x milligrams, because now we want to know how many milligrams are in 2 ml. And then from our label, we have that it's 50 milligrams. So cross multiply 2 times 50, x times. So 50 times 2 is 100. 1, cancel, divide by 1. X is equal to 100 milligrams. Using dimensional analysis, so the variable that we want we'll leave as a numerator. So 50 milligrams over x milliliters. We want to cancel milliliters, so we'll put that as our numerator in our next set of problem. So 2 mLs. mLs cancel. 2 times 50 divided by 1 is equal to 100 milligrams. Calculating the ratio strength. So a ratio strength means A to B. So that means A parts of pure medication and B parts of a liquid solution. The units indicate in a ratio strength are always A grams per B milliliters. This formula is the unit rule that is used for indicating the percent strength of medication. So for example, 1% solution can be written as 100, and thus that would be, the units would be 1 gram for every 100 milliliters. So how many grams of pure medication are in 500 mLs of a 1 to 3,000 solution? So we want to know how many grams are in 500 mLs. And we have a 1 to 3,000 solution. So basically that's 1 gram per 3,000 milliliters. So let's set up our ratios in proportion. So 500 mLs per X grams is equal to 3,000 milliliters over 1 gram. So we're going to cross multiply. X times 3,000 equal to 1 gram times 500 mLs. Divide 3,000 liters on both sides, and we get 500 divided by 3,000 is equal to 0.4. Using the basis, so we'll put the units as numerator for that we will know. So 1 gram over 3,000 times 500 will cancel. 500 divided by 3,000 is equal to 1.7. Sorry, 0.7 grams. So how many milligrams you make 3 mLs of a 2,000 million? So let's use 2,000 grams. So 3 ml over x gram equal to 200 milligram cross multiply, divided by 1,200. Okay, so looking at number 18 here, it says how many milligrams of dexamethasone are contained in 8 mLs. So looking at our label here, we see dexamethasone, sodium phosphate, and the important part to look at is the concentration, which is 4 milligrams per ml. Okay, so in doing so, oops. We can go ahead and start writing our problem. So from our problem, we said that it, change the color here. We saw that it was 4 milligrams per ml, and it wants to know how many milligrams are in 8 mLs. Okay, so let's set up our problem. So 4 milligrams per ml is equal to X milligrams for every 8 milliliters. So now we're going to go ahead and cross multiply. So X milligrams times mLs is equal to 4 milligrams times 8 mLs. And we're going to divide by our mLs, 1 ml. So our mLs are going to cancel. So X is equal to 32 milligrams. Okay. So let's go ahead and move on to the next problem. Okay, so looking at problem, let's see, which one should we do? Okay, let's do number 16. So it says how many milligrams of midazolam are contained in 5 mLs. So looking at this label, we can see that we have a 25 milligrams per 5 ml. And underneath in black, you see that you have a 5 milligram per ml. Okay, so we want to go ahead and use the concentration rather than using how much total volume there is. Okay, so let's go ahead and use that concentration of 5 milligrams per ml. That'll just give us an easier way of doing the problem. So let me go to the whiteboard. So then we have our concentration of 5 milligrams per ml. And we want to know how many milligrams are in 5 mLs. Okay, so let's set up our ratios in proportion. 5 milligrams per ml is equal to X milligrams per 5 mLs. And again, we're doing this because we want our numerators to be the same and our denominators to have the same units. So milligrams are on top, mLs are on the bottom. So let's go ahead and cross multiply. So X milligrams times 1 ml is equal to 5 milligrams times 5 mLs. And we're going to divide by mLs because we want to cancel. So we're left with milligrams. So X is equal to 5 times 5 is 25 milligrams. So there are 25 milligrams in 5 milliliters. So I'll go ahead and stop here. That's what you guys will be doing for homework. If you have any more questions, please feel free to email me and I'll respond to you as soon as I'm able to. Okay? So see you in the next video.